If you are producing a histogram with lattice, the function for that is called histogram, then you would state the tilde and the name of the data subset. In this case, I'm using the sepal.length column of the iris dataset. Logically, you do not need to state a y value for your histogram, therefore the left side or the y side of this formula is empty. But what you could do is you could specify a grouping factor by indicating a vertical dash and then the name of this data subset. In this case, I am again using the species subset of the iris dataset. Please note that the text arguments are quite the same as in RBase. So we have again xlab, we have main, and we have a subtitle indicated by sub. I'm again using the layout argument to specify how my panels within that plot are arranged. In this case, I want 3 columns. And I'm specifying type equals density. I could also choose between types % and count. So let's plot those 3 lines. And as you see, this is our first lattice histogram. We have 3 panels, 1 panel for each species. The next plot type I want to show you is the QQ plot. This is a quantile plot. They are actually quite useful to check what distribution your dataset has. The command for that is QQ math. And then you would use quite the same arguments as in the histogram. We do not need to specify the y values. We can incorporate a grouping factor with a vertical dash, and we also need to state the name of the dataset. So if we run this line, in this case we would have a normal distribution if the plot appears quite linear. The setosa panel in this case would be a classical example of a normal distribution. If we actually want to change the distribution to, let's say, a uniform distribution, we would use the argument distribution, and in this case equals q unif. And if we would run this line, we would see that our data does not exactly suit the uniform distribution. So that was the QQmath function. The next thing I want to show you is the box plot in lattice. The command for that is bwplot. You would then indicate the dataset by data equals iris in this case, and then you would use the formula. So if we would run this one, you would see that we get a box plot consisting of 3 boxes, and they are grouped again by the different species. If you want to produce a violin plot instead of a box plot, you could use the same line, but you would then indicate panel equals panel dot violin. And this violin plot gives some more information about the distribution within your dataset, as we can see over here.